Welcome to a lesson with Dr. Pal. Let's take a look at how we can get the OI part of the complex multiplication when we're finding the um, the area of a triangle um, in another way, where we're not actually writing down the imaginary parts. It really is the same way, but it's just written differently, I suppose. Let's look at an example again. Okay, so let's just look at something like, okay, something like this, some triangle. Suppose this is something like 2 plus 3i. Suppose this is like 5 plus I. Okay, so what do we do in the OI process? Let's use this part for the ground. So 5 minus I times this. Then we're looking at the OI. The OI is we do outside and inside right here. So we go 2 times so we have 2 multiplied times -1, just looking at the coefficients, and plus 3 times 5. So 15 minus 2 is 13. Okay, so 13, then you divide by 2, right? So we just found the area. Now, if we didn't divide by 2, actually, we would end up putting 2 of these triangles together and get the area of a parallelogram. So if you don't divide by 2, it's still very nice. You get area of parallelogram. Okay, with these side lengths. Very nice. Now, let's think about how we could write this out using something called a determinant. Okay, so what we could do is we could write out the ground vector, write its components, 5, 1 first. So the ground goes on the top. Assuming that we have a counterclockwise thing to ensure a positive result. So ground on the top, and you write it like this. We're going to write a 2 by 2 matrix with 4 entries. So the ground goes on the top, and the other one goes down below it here, which is 2, 3. So we write that out, 2, 3. Now a determinant works this way. We take a product this way, and then we take a product this way. We subtract all the products that come from a negative slope down, and when we have this product here coming from, or a positive slope, sorry, that's okay, it's reversed. Sorry for saying that. All right, but nonetheless, okay, if you go this direction, 5 times 3, that's positive. Then you subtract 2 times 1. All right, that's better. 5 times 3 minus 2 times 1, that's 15 minus 2, which is 13. So we found the area of the parallelogram by using this kind of determinant technique. Now notice where this comes from. You're doing opposites, like 5 and 3 and 1 and 2. That comes from OI. Now which part is negative is the outside part is always the negative part, the outside. So you just want to arrange your determinant so the outside happens in this diagonal. However you can do that is great. You could have rearranged this, so you could have put the 1 down there and then the 2 up there. Let's see, would that have, okay, so that would have been, so then you could have written this as 2, 3, 5, 1 as columns, right? You could have written this as columns, 5, 1, and 2, 3, and notice that it would have given the same result. So your vectors can be written as columns as well, not just rows. So 5, 1, 2, 3, and you would have gotten the same result, 13. But notice that in both cases, the ground always, so the ground is at the top or the ground is at the far left in this particular case, and then we would get a positive result for that area. And if it was switched, it would be fine. You just get the negative of the result, so that's okay too. Anyhow, I hope hope you were able to follow that, and thank you. Thanks for watching.